Good morning. Welcome to Wednesday's maths lesson. It's another one involving triangles and solving problems with them. So let's have a look at our first problem. Kate and Ebo use equal lengths of wool to form these triangle frames. Find the angles A, B, C and D. So now I want you to look at the type of triangles they've formed. Is it an equilateral triangle that they've made, an isosceles triangle, or a scalene? They're both isosceles, aren't they? We can tell that because we know already that an isosceles triangle has two equal sides and two equal angles. And we can see that on this, the first one, we've got two sides that are 2 meters in length. On our second triangle, we've also got two sides with 2 meters lengths. Let's go back to our first triangle. We know our sides are 2 meters long, but let's look at the angles. So we've got the angle at the top is 30. So therefore, angles A and B must be the same. And the same goes with that second triangle. The angle at the top is 100. So angles C and D must be equal. Let's see how we can work this out. The two lengths that are equal, in maths, we show that by putting a little line on both sides that are equal. Then you always know that those sides are the same length. So if our top angle is 30 degrees, then our other two angles must add up to 150. I know that because I've done 180 take away 30. And of course, we know from the work we've been doing over the last couple of days that angles in a triangle add up to 180 degrees. So if one of them's 30, then the other two must add up to 150. Remember that in an isosceles triangle, those two angles are equal. So we can do 150 divided by 2, and that means that each of those other angles is 75 degrees. Let's have a look at the other. So this time, top angle is 100. So 180, take away 100, which means our last two angles add up to make 80. Half of 80 is 40. So angles C and D both equal 40 degrees. They form a new triangle frame with two equal lengths. One of the angles is 80 degrees. What could the other two angles be? Now, it doesn't tell us, does it, which angle is 80 degrees? I think you might need to draw a diagram to help you with this one. The 80 degrees could be at the top between the two equal sides, or it could be one of the equal angles. So if the 80 degrees is at the top between our two equal sides, we would do 180, take away 80, divided by 2, which means that the other angles would each be 50 degrees. But if our 80-degree angle was one of our equal angles, that would mean we would have two angles at 80 degrees. So 80 plus 80 is 160. Now I'm going to take that away from 180. So 180 take away 160 gives us an angle of 20. So our missing angles would be 20 and 80. So I want you to complete this one. It says calculate the two missing angles in each triangle below. So in A, our triangle is the same way up as we've been looking at all of them. So 28 is our different angle, and our two missing angles are our equal angles. So 180, take away 28, and then divide your answer by 2. We're going to use that same method in B. The only difference in B is they've turned the triangle upside down. If you redrew it the right way up, you would see your 112 is still at the top. It's still the angle between our equal sides. So that means our other two angles are the ones that are the same. So do the same thing, 180, take away 112, and then divide your answer by 2. Don't forget to divide your answer by 2 because you are looking for the amount that each angle is worth. C is a bit different, isn't it? It's lying on its side, so we could turn it round so it's standing the right way up. But 70 is not the angle between our equal sides. So therefore, 70 is one of our equal angles. This means we're going to have two lots of 70 and another amount. So 70 plus 70, and then take that away from 180. You can draw a bar model to help you. There are the answers. You've had a go of your own. Now on to the practice book. Question 1. You're going to need to redraw these out and then mark on with those little lines I showed you earlier so that you can show which sides are equal. Question 2. The equal sides are shown for you this time, but some of the angles are missing. So in A, your equal angles are missing. In B, you've been given one of the equal angles. You're going to have to work out the others like we did earlier. And in C, you've been given the angle that's not equal. It's put a square in. What does that mean? You can always go back to yesterday's lesson to have a look. Question 3, you're going to need to redraw these again, marking on the equal sides and the equal angles. Now, question 4 is a bit more of an investigation. Amelia draws an isosceles triangle. One of her angles is 56 degrees. Bella draws an isosceles triangle. One of her angles is 156 degrees. What are the other two angles in each of the triangles? Now, Amelia says that her question has two solutions. And Bella says, well, that means mine has two. But does it? The first thing I would do to solve this is draw out each of their triangles. Remember, can the angle that we've got the number for, the measured angle, could that be one of the equal angles? Or does it have to be the angle that isn't equal? Draw them out and see what you think. There are two challenges for those of you who fancy doing that today. If by this point you're thinking, oh, this is still a bit tricky, then have a go at these ones as well. When you've finally finished, what I want you to do is go on to the next slide and mark all your work. Once you've marked it, make corrections. Don't just leave it wrong. If you've got an answer wrong, go back through this video and have another look. Can you work out to solve it? If not, put a message on your piece of paper so when you photograph it, Miss Barnett and I can respond directly back to you. Don't forget to do your reflection. Remember, creating a missing angle problem involving an isosceles triangle will also need an answer. And then finally, you've got your answers on your last slide. Have fun today. Bye.